briefly about function arguments. If you look at this function definition, print hello, you can see that there are two names in the function definition. Compare this to what we saw before. In this definition, there's nothing in those parentheses. The parentheses are designed to hold function arguments. Function arguments are basically objects that get sent up to the function when the function is called. I want you to look closely at the fact that we're passing two arguments to print hello. What this definition here is saying is that this function expects two arguments. We can say it expects two arguments. The fact that those names are there means that the arguments are expected by the function. It means that we must pass the arguments in order for the function to work. Let's run this function and see what we get. So you can see this function is somewhat versatile. It allows me to send a greeting that is kind of a greeting like hello and then a place. Hello world, bonjour Python, squawk parrot. The function is expecting two arguments. These two arguments, which are objects like any other, and by the way, we can make them variable names as well. They certainly don't need to be literal values. These arguments are required and they are copied up to the function. Again, from last video, you know how to read this program. It's going to start at line 5. That is, Python will begin by storing line 1, 2, and 3 as a function. But then it's going to start on line 5. It'll go from 5 to 6, 1, 2, 3, back to 6 and on to 8, 1, 2, 3, back to 8 and on to 10, 1, 2, 3, back to 10 and then onwards. What's different about this function, of course, are the two arguments. Now look closely at your output and compare it to what you're seeing on line 3 when we're printing the full greeting. What is full greeting made up of? Well, it's made up of greeting plus a comma plus a person plus an exclamation point. So we're seeing hello world or bonjour Python. Taking a look at bonjour Python, you can see the reason that we see bonjour Python with an exclamation point is because the two values that we passed up are the string bonjour and the string Python. So what can we say about greeting? We can say that greeting will hold the value of the first argument passed in the function call. So the first time we call the function on line 6, we're passing up hello as a string and world as a string. Since we go from 6 to 1, what we're seeing is that greeting will be hello, the string, and person will be world, the string. That's why when we concatenate the strings together, we're seeing hello, comma, world, exclamation point in the output. The greeting and person names are variables. They're variables just like any other variables that we may have encountered. What's different about them is that they're assigned in the function call. It's almost as if we said greeting equals hello and person equals a world. It's almost as if we said that. And in fact, it is that we said that, but we don't say it syntactically this way. We're not saying greeting equals hello and person equals world. What we're saying is pass up hello and world, and these will be assigned to greeting and person. The next time we call print hello, pass up bonjour and Python, and it will be assigned to greeting and person. Pass squawk and parrot, and it will be assigned to greeting and person. In this way, our function can be made to use with varying inputs. We can call it with any two string arguments that we'd like. When we do, those two string arguments will be copied up to the variable names greeting and person. And in the function, those variable names can be used to make use of the values that were passed up. Here's another very short example. We're calling the doublet function, which we defined on lines 13 and 14. As you know, the program flow will go like this: 16, 13, 14, back to 16, then on to 17, 13, 14, back to 17, and then on to 18, 13, 14, back to 18, and then onwards. As you can see, the value that we're passing is getting doubled in the print statement. Why? Because 5 is being assigned to num, and then we print num times 2, 10. Then 101 is being assigned to num. We print 202 and then move on. 1.4 is being assigned to num, and then we print 2.8, or 1.4 times 2, because each time that we call doublet, num is getting reassigned.